Now let's take a look at this figure 17-10 from Stallcup's Electrical Design Book, Volume 2. And notice in the illustration you have your transmission lines and voltage routed to a substation with transformers. And then, of course, you bring your distribution lines, as shown here, overhead to a point, and then you go underground in accordance with 230.208, and you hit your disconnects by that section, and then you could have sub panels or whatever. But now remember, we're dealing with over 1,000 volts here. So these service conductors and the cable should be protected at what value? Continuous rating of each fuse shall not exceed 300% of the service conductor's ampacity rating. Now that's using fuses that we select from 490.21B as in boy in the code. Circuit breaker strip setting shall not exceed 600% of the service conductor's ampacity rating. And then notice if you should use a electronically activated type fuse, you could go up to 600% even on a fuse when you review 240.101 in the NEC. Now, continuous rating of each fuse shall not exceed 300% of the conductor's ampacity at the service equipment and so forth. And circuit breaker strip setting should not exceed 600% of the service conductor's ampacity rating. And then again, using electronically actuated fuse, you could go up to 600% there. Now notice this protection requirement scheme can be read and in detail in 230.208, 240.100, and 240.101A in the NEC. Now for protection of these transformers you see in the illustration, just go to table 450.3A and you can pick up the same percentages that you see here for these conductors. And you know those percentages, they raise those percentages up like that usually when they have in the facility equipment with requiring, inrush current to start and operate and drive a particular load. But remember one thing, Article 450 protects the transformers, table 450.3A. And 240.100 and 240.101 protects the conductors, and that's what this illustration 17-10 is illustrating.